Welcome everyone to my presentation that is towards analyzing the impact of go-arounds at occurrences at large European airports. So I'm presenting this work on behalf of my co-authors, Ryan Arcole, Esther Calvo-Fernandez from Eurocontrol, and Manuel Walter from Zurich University of Applied Sciences. So I will start my presentation with a short introduction. Then I will present the datasets we have used to make this study. Then I will introduce some statistics on go-around rates, as well as some statistics on go-around portions themselves. And finally, I will dive into the impact, trying to analyze the impact of go-arounds on the other arrival traffic. And then I will conclude and give an outlook at the end. So for those who were here last year, my colleague, Raphael Manstein, did a presentation about a large landing trajectory dataset for go-around analysis, in which we collected, I think, 9 million landings all over the world, but I think more than 100 airports around the world for the year 2019. And inside, we labeled go-around so that we could analyze them. And after the presentation, we got contacted by Eurocontrol, by the performance review units, and they told us, well, this is very interesting, and we would be happy if you could extend the study for not only for 2019, but for 2019 until 2023. And because we're so happy to see that we're not the only one very interested with go-arounds, because for those who know, that's already the third paper we do at OpenSky on go-arounds. Obviously, we said yes, and we collected more data. And actually, the results of this analysis, if you had a chance to read the latest performance review reports, are inside this report. So today, I will give you a bit of insight of what's in the report, but also some new things, such as trying to really evaluate the impact of go-arounds on the other arrival traffic. That's really the novelty of this study. So the data sets. So we started to collect OpenSky data, ADSB data for, I said, from 2019 until July 2023. And we focused this time only on European large airports. So we selected 20 airports. I won't list all of them, but they are on this figure. You can read them. And so the first thing is, once we retrieved the landing trajectories, we had to only keep commercial aviation. So we remove everything such as piston engine aircraft or calibration flight services, because they introduce a lot of bias once you try to analyze the go-arounds. And then we identify the go-around. So using the traffic library from Xavier, how does it do this? It's basically if a landing is aligned 2 times on the runway, and those 2 segments are separated by 1 climb, then we assume that this is a go-around. So this is not perfect, but from what we have seen, it works very decently. So we collected 6.7 million landings, and out of the 6.7 million landings, we have identified more than 20,000 go-arounds. So then Eurocontrol was also interested in other information, such as, can we see some different go-around rates for different market segments? So the typical question is, for example, are low costs doing less go-arounds because of economic pressure? Those kind of questions. So we had to include the market segment, so we could retrieve this data from the Eurocontrol Network Manager datasets, so the UNM datasets, and we could kind of merge our ADSB trajectories with this information. And then there was also something else we needed. So we realized a bit later that if we want to assess the performance of the landing traffic around an airport, it would be nice to use the arrival sequencing and metering area. So this is basically a cylinder of 40 nautical miles around the airports. And every time a landing enters the cylinder, we try to retrieve the position, so where, when, and what was the bearing, so basically between where it enters the cylinder and the airport. So in theory, we can do that with ADSB trajectories. We don't need Eurocontrol data to do that. The problem is, when we collected the data, we didn't know that we will need this use. So we were a bit greedy, and we selected the 2 small portions around airports to do this. So we had to use the Eurocontrol data. So I will just show you some statistics that are also, I think, in the Eurocontrol report. So if we look at go-around rates per airport, we see quite a large variation. So for example, on the left, you have Rome, which is showing 1.5 go-around every 1,000 flights. So usually we express the go-around rate in number of go-arounds per 1,000 landings. And then on the other side, you have where is the point? Istanbul, where you have above 6 go-arounds per 1,000 flights. So that's very large variation depending on the airport. If you look at the mean, we're somewhere just above 3 go-arounds every 1,000 landings. So why do we see such big variations? Unfortunately, I don't have the answer. And I think this is a nice use of this data set because that's something that can maybe be explored. Is it only due to weather? Is it operation? Is it runway configuration? So many different sources can be assessed. So the next question was, okay, is there a difference in go-around rates depending on the market segments? And what we see is that mainline, low cost, and cargo are somewhere in 3.3 range, 3.3 go-arounds every 1,000 landings. While if you look at regional, non-scheduled, and business, you are a bit on the lower range. So again, I don't have the answer for why we have such variations. One assumption could be they don't use the same type of aircraft. Maybe the regional jets are lighter, and maybe it's a question sometimes of energy management, and maybe it's easier than on regional jets. And that's what we will see in the next slide. Is now if we look at the go-around rates per aircraft type, we see also big differences. So from 1 to more than 4 go-arounds per 1,000 landings, depending on the aircraft type. So what's interesting here is basically, if you look on the left side, we have the A380 and the 747, which are the two jumbos. So heavy ones tend, I think, to have higher ground rates. But what's also funny is that if you just look in between, we have the C series, which is just in between, which is not heavy at all. So could be a good question. Why? Is it because it's a new aircraft? I don't know. I don't have the answer. And again, that's something maybe we can investigate with this data set. So after looking at those rates, we're also just interesting, usual question is like, okay, well, go around is not very comfortable for the passenger, but how long does it last? Are there differences between the airports? So for that, we analyzed only the go-around portion. So that's, for example, just those little trajectories you can see here. And that's really, we took it from threshold back to threshold. So if we look at the box plot, so the distribution of times a go-around occurs at different airports. So we see some variation between the airport, but this is not too big. If we look, most of the time, actually, a go-around lasts between 10 and 20 minutes, almost all the airports. Of course, we have a lot of outliers. You have some go-arounds which are very long. For example, if we look, the highest outlier, it's in Paris. We saw a go-around that lasted for more than 2 hours. That's this one. So landing on Paris Charles de Gaulle, oops, and then went into holding for more than 20 holdings and then landed back. So I tried to Google the call sign on the day just to see what happened. And unfortunately, I couldn't find anything, but probably a technical issue with these flights. So the next question was, okay, how much extra miles do they need to fly? Are there big differences between the airports? So this is very correlated to the time. So I'll go around, you fly extra between 35 and 70 nautical miles most of the time. So if we look at the interquartile range. So again, not so much new information here, a lot of outliers as well. And the next logical question is, okay, but how much extra fuel do you need to perform a go around? So here we use the OpenAP from UNZ to compute the fuel. And instead, to do kind of a fair comparison between the airports, we just look at the A320s, just not to have the traffic mix having too much influence between the airports. So what we see is that, again, a go around, you consume between 350 and 600 kilograms of fuel most of the time. Okay, so this was also something interesting with FONT. So now comes the real analysis, if I may say. So how do we assess the impacts of go-arounds on the other arrival traffic? So we use this ASMA methodology. So if you're not familiar, so it's every time an aircraft enters 14 nautical miles from the airport, we try to compute what is called the unimpeded time. And basically that's kind of a reference time, is how long normally should it take for, when it's not congested, for an aircraft to enter until it lands. And how do you do that? So you need to group for a given runway, for a given aircraft class, and a given entry sector, you need to define this reference time. So first, what we needed to do on our trajectory, so we knew the the runway, we knew the aircraft class, and we needed to identify which sector it entered the ASMA. So to do that, we retrieved the bearing distributions, and then we kind of clustered the modes of the distribution of the bearing. So all the aircraft entering, for example, 0, to 90 belong to the first sector, and so on and so forth. So here, normally at 0, 360, you have a discontinuity, which makes the clustering quite difficult. So you can use some circular statistics, which are quite fancy, but here we went very easy with the kernel density estimation. We retrieved the mode of the distribution, and then we could kind of identify the entry sectors. So once you know the entry sector, you retrieve all the times from those landings from the entry sector that it took, and then you take the 20th percentile, and that's kind of your reference time. So for each landing, we know the landing runway, the entry sector, the aircraft class, and the ASMA time. So we can actually compute what we call the additional ASMA time, which is just the difference between the observed time minus the reference. So if this time is positive, it means that it took longer than in uncongested environments. If it's negative, it means that it was very fast. So now, how do we use it for go around? So you can imagine you have a landing sequence. So for example, you have a landing, it was 6 seconds slower than the ASMA time, and so on and so forth. Suddenly you have a go around, and then you have some other landings, and you can use the ASMA times. So what we did is we defined this kind of reference. So we looked 20 minutes before the go around, we retrieved all the landings, and we took the median additional ASMA time there. And then we compare it with a window 10 minutes after the go around. Do we see a difference or not? If this difference is positive, it means that it took more time for landings after the go around than it took before. So we retrieve this difference. And that's for one go around. And imagine at an airport, you have, I don't know, 1,000 of go arounds. We do it for the 1,000 go arounds. So during this window, and then we retrieve the median. Okay. So then we did it for the 0 to 10 minute window. The next step is for the, we shift this window by 1 minute. So for 1:11, and so on and so forth until 1 hour after the go around. We always compare to 20 minutes before. So this is, for example, what we obtained for Zurich Airport. Ooh. Okay, don't know what happened here. I will just let you know. Oops. So normally here are the windows. What you see is normally, so it starts here at 0, and then it's, okay, if I remember correctly, here we're somewhere around 12, 22 minutes after the go around, all the way to 1 hour after the go around. Okay, don't know what happened here. So what we see is that even my Y scale is completely messed up. So what we see here is that it was increased up to 80 seconds. So what we see is that after the go around, this time increases from 0 to 80 seconds. So it means landings 25 minutes after the go arounds are taking in median 80 seconds more than it took before the go around. So it has kind of a huge impact. And what we see is that normally it takes more than 1 hour to go back to pre-go around levels. So that was what we're supposed to see here. So I showed it to, yeah, oh, maybe if you put the, it's Linux issue? Yeah, but okay. Thank you. So when I showed it to my coworkers, they were like, "Oh, that's super cool." But how are you sure that this is due to the go around, what you see, and not just a random variation in your data? So it's like, yeah, very good points. Let's do it exactly the same, but we random sample some landings, and we do exactly the same to see if we observe the same behavior or not. And we did it 10 times, and okay, here it's still no. I don't know, it was a PDF plot inside. But it's not even the right slide. I don't know why it's not. Yeah, but I mean, there are curves missing in the plot. Okay, so normally what you should see, what you will see in the paper is that there are more curves on those plots where you see the reference. And actually for the reference, it always fluctuates around 0. And we really see that the red curves are outliers. So this is kind of a strong sign saying, okay, those variations are due to go arounds. Oh, here, no, we have a y-axis and the x-axis, but not missing curves. Interesting. So you can see that for almost all the airports, we have kind of the same behavior with an increase of the time and then a slow decrease back to pre-go around levels. And what we see is that for some airports, the difference is huge. So for example, for Dublin, and I have no idea if this is related to point merge or not, but we see that it takes more than 100 seconds. I mean, for landings in the range, more or less 20 minutes after a go around to land than it takes before a go around. And for example, if we look at airports such as Madrid or Paris, then we can see that the impact is much smaller, for example. So that was one of the insights of this. So a bit of conclusion. So thanks to this big data set that we're releasing, you can really do a lot of analysis on go around and trying to understand them better. We see a lot of variations depending on the airport or the aircraft, for example, and that would be very interesting to use it trying to analyze why do we see such variations? Is there anything we can do to try to reduce this number of go around? So I must say that, I mean, go arounds are not that bad, right? It's normal procedures. That's for safety, so we need to have go arounds. But if we can try to reduce them to the lowest, it's even better. Then on the impact analysis, so we analyze the impact of a go around not only on the flight itself. So okay, of course, it will fly longer, consume more, and so on. But it also disrupts the landing sequence afterwards. And I think now there is a lot of optimization, which is on the runway side, trying to optimize the throughput of the runway. And sometimes we need to make sure that this optimization does not increase the go around rates. Otherwise, you might offset all the gains of this optimization by just actually delaying the rest of the flights and obviously consuming more. So that was kind of my point, is that you can use this kind of study to make sure that when you do your cost benefit analysis, to make sure that you include that into it. So yeah, so that's it for my presentation, and thank you for attention.
Thank you so much, Benoit, for this presentation. Do we have any question in the audience? No.
Hello. Do you hear me? Yeah. Thank you for your presentation. My question was, why did you consider 20 minutes before or after, and 10 minutes instead of choosing like the same time, 10 and 10 or 20 and 20?
That's a good question. It's just sometimes in 10-minute window, you don't really have a lot of landings. And it was to make sure that, you have enough landings to have kind of a representative time. So we take the median because, okay, it's AGSB data, so we know there is noise. And sometimes, you might have some outliers that might, perturb the measurement. So by taking 20 minutes, and the median on 20 minutes, we were kind of confident that this is a good reference time.
Hello. Okay, it's getting better. Two questions. First of all, if you have a multi-runway system, then it's a little bit more complicated, right?
So I don't know if it's more complicated, but at least here, we did the analysis at airport level. So maybe, for example, for Paris, when we see it as less impact, it's maybe because they use also another runway at the same time. And obviously then, you don't see the increase that much. So if you do it at a runway level, maybe then you really see an increase everywhere.
Yeah. Okay, I did some, not similar, but some analysis on Frankfurt Airport, and then they have a very operational concepts with very over time, over wind conditions, over something like, and then this operational procedure really drives some of my data as well. So I have to filter the data first about the potential operational concept, and then the next one. And the other one is a little bit technical. You said very easily that it takes a circular statistics. I got some trouble because it's a circular statistics has a Mises kernel or has some kind of normal distribution. And these are not that very, how do you say this, peaky sometimes. So I was hard to really fit in a Gaussian curve in there. And I was not able to do so. So I decided to tweak around a little bit. Let me say like this. Do you have some similar experience, or does it always work?
Yeah, no, yeah, that's a good question. That's why I didn't use circular statistics, because it was too complex for me, and I would have had to use R to do it. So that's why then we went for the kernel density. And then we have a trick that we say, okay, if those two peaks on the left and on the right are less than 15 degrees apart, they're the same mode. So that's kind of a trick.
Yeah, my trick was I copied it 3 times, one to the left and one to the right, then make the statistic and then cut it out finally.
That's smarter.
Yeah, but okay, it's nice to see that you got the same problems. Thank you.
Hello, good morning. A couple of questions. The first one, you say at the beginning that you need to go in depth on the difference, if there are any, on go-arounds, depending on the type of operation or the type of operator and things like that. But I miss a little bit this information, or at least it was for me quite reduced. I expect a bit more detail on that. And the second question is, I understood that you took 20 minutes before and 10 minutes after. The 20 minutes before is to have enough time. And the 10 minutes after, I suppose, is not to be influenced by other factors like the change on the density of the traffic or things like that. But how you go to the 10 minutes? Is it just a selection, or you make some kind of sensitivity analysis? Or?
No, we chose 10 minutes since the beginning, and we could clearly see by choosing 10 minutes. I mean, normally we really see the increase in the curve, so we were okay. That's good enough. We kind of show that it impacts the traffic, and that was our goal. But maybe that's something we can do later on to see really like being more fine-grained on the size of the window.
And the second question, the one of the difference between the type of operator, operations, and so on, you could elaborate a bit more, please?
You mean on the market segment? To elaborate, sorry, on the results, or?
Yeah, you say that you were asked at the beginning. One of the things I love of this paper at the approach you have is that it's a second step in a process. So you have a previous paper, then you present that, and that means, for me at least, that you have more time for analysis. That is something, operational analysis, that is something that I miss in some of the papers. This kind of operational analysis is well related with this kind of operations. So what I would like to know is, if you have plans to do more, or if what you have shown here is just what you have presented, because I have quite a lot of interest in that.
Yeah, so I mean, we're always happy to continue the work of Lucy on that, and we have been, I think, asked from the PRU to do it again for this year. I mean, I think, you know, sometimes we like a bit the operational context, and if you really have some points that you'd like us to analyze, we're more than happy to collaborate and to do it. Yeah, of course.
I'm ready to do that.
Perfect.
I don't know. Yeah, let's say it works. Have any movements to go around going consecutively?
Yeah, so yes, there are some go-arounds that are doing multiple go-arounds. Sometimes they go to another runway. We see that for the analysis, for example, of the time, we just took really from the first time until the times it aligns again. So basically, the first.
Might have changed a little bit the mean, but I mean overall.
Yes, and that's maybe one of the also of the issue of taking the median, is that maybe okay, we remove the noise, but maybe we also remove some information from the mean.
Course,
yeah.
And in both cases, did you notice any higher disruption, or it was just like those 90 seconds?
You mean if we take the mean?
There were several go-arounds.
So since the beginning, we didn't consider them.
Okay, you just
yes.
took it out. Okay.
Yeah.
Thank you.
Any more questions?
I didn't get it. Did you also do an analysis on aircraft operator kind of impact?
Yes, at some point I did it. It's not included in the paper. The reason is it's very influenced, you know, by where they operate as well. So I found that actually looking just at the airport kind of gives you, you know, for example, if I look Swiss in Zurich, their ground rate is more or less the one from Zurich. So it's very difficult then to factor everything and the reasons why. Yeah.
You think that it should be a more spot-on kind of analysis, looking at operators per airport and to see if there is a sort of recurring pattern.
Yes, exactly. So I started to do that. The problem is, you know, go-arounds are not that many. So you really need to find an airport where you have enough go-arounds from enough operators to really understand what happens. And so we need just, I think, a longer period of time.
You have Istanbul.
Yes, but the coverage in Istanbul is...
I want to thank you for your work, and I look forward to more analysis. So I'm going to ask a question. I don't think you addressed it, but maybe you've done other work. In terms of the relationship between go-arounds and the number of operations observed? Do you have some idea?
Maybe just slightly before. So you mean on the number of movements we observe at an airport?
So like how busy the airport is,
Yep.
and specifically during, like during high periods of busy traffic, right? Lots of operations, arrivals, departures. There might be an incentive to make that slot, right? As opposed to, okay, I'll suck it up. I know it's bad weather, especially in bad weather, IFR conditions, where we see the capacity of an airport drop. So SFO is a good example of this, where capacity drops by half if there's bad weather. And so there might be an incentive not to have a go around and just stick the landing.
Yeah, no, that's a very interesting point. We didn't go that far yet, but
I look forward to it. It's really cool stuff. Thank you.
Good.
Work together.
So I know this was brought up elsewhere, but so I'm over at the University of Central Florida, and we have access to the FAA's SWIM network that does have air traffic control or air traffic management decisions. And so there might be something there. So I'll put that as an offer.
Okay, now that would be very interesting, because really knowing why there was a go around, is it like from the crew, they decided because the approach was unstable? Is it because the runway was occupied and the ATC is instructing the go around? I mean, yes, we don't know.
Room for cooperation together with Ramon, and his secret sources of data. Oh yeah, for your PhD.
Thank you.
Any more questions? If not, then let's thank Benoit